Hey everyone, and thanks for tuning in for putting the sec in DevSecOps, automating cloud security as an enabler. My name is Payton O'Neill, and I'm head of growth marketing for Bridgecrew by Prisma Cloud. We're part of the Palo Alto Networks family after our recent acquisition, and I'm super excited to chat with all of you. I spend a lot of time in my role thinking about and writing about and talking about the intersection of engineering and security. And in this talk, I'm going to be tackling a topic that's of particular interest for us at Bridgecrew and myself personally. That is how automation and automation-enabled processes can actually enable business by reducing friction between those two parties. So between engineering and DevOps and security and compliance. We're definitely going to be coming at it through the lens of cloud security, infrastructure security, and have a packed agenda. So I'm going to start out by giving an introduction to infrastructure as code, or IAC. Then we'll look at some of the problems facing DevOps and security that we as Bridgecrew see in the industry and within our community and within our own customer base. Then we're going to look at some of the tools that can help and also tools that can help us learn about infrastructure as code, about cloud security. Then we'll look at some sources of misconfigurations and cloud risk. We have some interesting research that I'll dig into around open source IAC. And then I'll look at some practical guidance for addressing cloud security throughout the DevOps lifecycle. That's sort of like the crux of this conversation. And then close out with some tips for implementing a cloud DevSecOps strategy. So let's get started. Before diving into the security aspect, I wanted to just quickly cover what the foundation of this entire talk is. For us at Bridgecrew, what makes cloud DevSecOps possible, and that is infrastructure as code. So infrastructure as code, commonly abbreviated as IAC. I'll kind of switch between IAC and infrastructure as code. It refers to the technology and processes used to manage and provision cloud infrastructure using code. So you've probably heard of frameworks like Terraform and CloudFormation. You could also, Kubernetes manifests function in the same way. There's declarative and imperative frameworks. So serverless framework, AWS CDK, Azure Resource Manager. The gist of it is that it transforms manual or script-based cloud provisioning into code. So there's a lot of advantages of this. One of those is that it makes cloud DevSecOps possible, and of course that's a lot of what we'll dig into in this talk. So for example, I just wanted to show sort of an example IAC resource. This here is a Terraform resource that would be used to provision an S3 bucket. And you can see all of that bucket's attributes are defined in code. Obviously, it's a very simple example, but you can see it's private and it has versioning enabled. And because it's code and because it's machine readable, it has all of the benefits of any other kind of code. So it can be version controlled. It's better for collaboration. It makes cloud provisioning more repeatable and at a greater scale. And of course, for the purpose of this talk, it enables better security controls. And basically, our sort of mentality is that if you're provisioning or managing cloud in code, you should also be managing security and monitoring it in code as well. But of course, that's easier said than done. While IAC allows us to manage sort of the sprawl and the sometimes manual processes around cloud provisioning, it also adds some complexity. It's a bit of a newer technology, and of course, with complexity can come risk. It becomes even easier when you have multiple people with multiple hands and multiple buckets to mess up a configuration, which can definitely lead to those headline making breaches, which obviously we do not want. So that's why we need to think about DevSecOps as it pertains to cloud security and why automation is so important. So with any software development, the sort of challenge that DevSecOps is aiming to solve is this at odds, these responsibilities between teams that are oftentimes at odds. So we have first, of course, DevOps, which is always aiming to move super fast and break things. Of course, DevOps aims to sort of combine development and operations functions to create better collaboration and have everything running within one pipeline. And it's really to codify and automate every single aspect of your stack. So version control, CI/CD pipelines to control build and deployment processes. And in that way, you can automate pretty much all the testing and delivery you need with a single pipeline or series of pipelines and processes. On the other hand, you have traditional security, which, especially when we're talking about cloud security, oftentimes lags behind what DevSecOps is trying to do. Existing cloud security tooling often focuses on detecting issues that are already sort of out there in the world. And when that feedback is surfaced and brought back to the development team or engineering or DevOps teams, that's oftentimes very repetitive and very time-consuming work, aka basically like a never-ending cycle of Jira or ServiceNow tickets. And it really doesn't solve the root issues. It doesn't prevent them in the first place, and it doesn't really help fix those issues at scale. It's really sort of reactive rather than proactive. This tooling is typically, and workflows typically not designed for DevOps or developers. And until very recently, it hasn't really understood the full context of multi-cloud and or multi-IAC frameworks. So if you're asking yourselves, why do we need to put the SEC in DevSecOps? This is why. But that kind of comes with its own set of challenges. Shifting security left, you've probably heard of shift left security, adds sort of its own set of challenges. With developers being expected to address cloud security concerns, that's a whole lot of extra work on top of their day jobs. And in order to do a really good job, you have to be on top of tons and tons of security best practices, compliance policies, and be able to take these sort of abstract best practices and apply them to your own infrastructure. Not a small task at all. Take just one example, the CIS Center for Internet Security Kubernetes benchmark. This is now in version 1.6.1. And it's just a single set of security benchmarks just for Kubernetes, and it is 263 pages long. So that's dense. There's no pretty pictures or anything. So having to remember every single policy, every single security rule check, et cetera, across all of your infrastructure as code frameworks, all of the languages and dependencies you're bringing into a project is really unrealistic. So that's why security teams have sort of taken it on themselves, and now why in this sort of the context of this talk and in the context of infrastructure as code, we're looking to automation to take that burden of manual security practices out of, to be more efficient and more of a business enabler rather than a blocker. So before we sort of move on to more of the guidance portion, I think it's important to understand what we mean when we're talking about misconfigurations. We're talking about vulnerabilities in sort of like an abstract sense. When we say misconfiguration specifically, we're referring to cloud configurations that are lacking a security or a compliance best practice, and so resulting in a misconfiguration that could result in, a cloud breach, any kind of cloud risk. About 95% of cloud security issues are related to misconfigurations, and a lot of these are just due to either lack of understanding, lack of knowledge, or just simple mistakes. So these are some of the sort of most common misconfigurations we've seen. Actually, Unit 42, a group of Palo Alto, recently did some research this spring and found 200,000 insecure templates in infrastructure templates in use. And these were some of the common misconfigurations. So unencrypted databases, about 43% of cloud databases were not encrypted, which of course can leave important customer data at risk. About 60% of cloud storage services had logging disabled, which of course can make it difficult to review audit trails in the event of a security-related incident, just some general best practice to have. And insecure protocols. So they found that about 76% of cloud workloads expose port 22, which was up year over year by quite a bit, about 20%. And 69% of organizations expose RDP or port 3389, which was up 30% year over year. So not good numbers. All of these represent some amount of risk. They allow potentially remote access of cloud environments to attackers. There's obviously a slew of other misconfigurations that can present business implications. And they also, if you're in a regulated industry, have compliance implications. If you're not compliant with some of these benchmarks, you are then risking losing compliance against frameworks like SOC 2 or HIPAA or PCI or whatever industry you're in that it's relevant, which can have a whole other type of business implication. So DevSecOps aims to find and help teams address misconfigurations, and as we'll talk about here, prevent them from even, being included in a cloud threat report in the first place. So this is where, for us, a developer-first approach to DevSecOps comes in. And when we say developer-first, this is what we mean. We mean codified, automated, and integrated. So codified, the dev-centric approach to cloud security for us puts IAC at its core, enabling teams to develop and secure infrastructure in the same exact place. It gives a common language so everyone has access to and can understand what misconfigurations exist and have a really solid version controlled spot to manage all of those misconfigurations and fix them. As far as automation goes, this isn't super novel. We've been using automation to do pretty much all software testing since software was a thing, whether you're doing unit testing or integration testing, or even for security use cases, static analysis of application code, software composition analysis, all these things are leveraging automation and code, machine readable languages to find and ultimately address security risks. So when it comes to cloud security, we definitely lean on the codified nature, aka infrastructure as code. And lastly, it needs to be integrated fully into the DevOps lifecycle by embedding cloud security into the tools and workflows that developers are already using. We believe it's truly the only way to have real security adoption, and it makes everything faster and a lot more frictionless. So now we kind of have an understanding of what misconfigurations are, why it's important to address them, and sort of the implications that they can have. Let's look at some of the tools that can help us find, fix, and prevent misconfigurations. and also some tools that can help us learn about misconfigurations. Obviously, a lot of the narrative around DevSecOps, and I think cloud security lately in general, has been sort of a finger pointing game. It's been about, developers need to learn security best practices, but I really think it's equal parts that, and that security needs to understand the tools and the workflows that developers are using. So many of these tools that I'm going to talk about are aimed at bridging that gap between the two. They're primarily designed with developers in mind, but I think they're really good tools for sort of cross-domain collaboration and cross-domain training. So the first and sort of primary tool that I'll talk about in this talk is Checkov, which is built and open sourced by Bridgecrew, is written by our CTO at the end of 2019, to really sort of solve this challenge of pre-resource scanning. So scanning of infrastructure as code, frameworks like Terraform. It started with just support for Terraform and then expanded into CloudFormation and Kubernetes and serverless frameworks, CDK, even Docker files. And it's got a pretty nice little community around it. Since its release, it's been downloaded about 2.5 million times. We have a Slack community, and there's been some awesome contributions. We actively maintain it. We recently released Checkov 2.0, which introduced a whole new sort of type of check that's much more context aware and can understand dependencies across resources, which is sort of the next level. We probably won't even get that advanced in this talk, but sort of at its most simple, it's used to scan infrastructure as code against policies. It has hundreds of built-in security and compliance policies, and you can point it at a file or a directory, and it will run and scan all of the IAC code blocks against its built-in policies. And if any of those are in violations of those policies, it will return that feedback to you in the form of alerts wherever you have it embedded. So you can run it locally via your command line on your local workstation, or you can deploy it in a CI/CD pipeline so that it's a little bit more of collaborative feedback, more automated feedback. And it also sort of, in that case, can sort of bridge the gap between DevOps and security. So we're going to talk a lot about that in this hour-long talk, but really like understanding the goal of Checkov to sort of fix misconfigurations in code, in infrastructure as code, rather than patching misconfigurations once they're already in runtime, is what this is all about. So it gives us sort of the same level of assurance as we oftentimes have with our application code. And it's sort of a new way of thinking of cloud security. So this is all well and good. I'm sure you're thinking, great, maybe you're new to IAC, maybe you're, not, this is still kind of abstract. One of the things I recommend checking out are GOAT projects. So we have 2, 3 that we maintain actually, and then several out there that are all vulnerable by design projects, meaning that they're riddled with security and compliance issues like the ones that we've already talked about. The 2 listed here that we maintain are CloudFormation GOAT or CFN GOAT and TerraGoat. The former is for CloudFormation templates and the latter is for Terraform files. And Kubernetes GOAT, while we do not maintain it, is a fantastic resource to understand Helm chart and Kubernetes misconfigurations. So one of the primary drivers, of course, for developing these projects is to help developers and security practitioners alike understand the risks of IAC and how to identify misconfigurations. Another reason we have invested in this area is to support the research and development of Checkov. So used in tandem, these GOAT projects and Checkov give sort of hands-on experience of finding and understanding misconfigurations. So for example, you can clone or download the TerraGoat or CFN repos, point Checkov at any of them, and it will return a laundry list of misconfigurations, like a lot. Very, very, very bad code. Do not deploy it in a runtime environment. It's, you know, very much for demo purposes only. And you can see in the comments what the misconfiguration is, and then you can see that Checkov can identify them. So really good tool for seeing really how easy it is to miss these things. You know, having a true false when you've got, you know, hundreds if not thousands of lines of code is not trivial. You know, those things stack up, and that's where Checkov comes in. So definitely recommend checking out these training resources. Great place to start if you're unfamiliar with infrastructure as code and IAC from a security standpoint. But if you're thinking, okay, cool, I use IAC, you know, we're pretty advanced, and, you know, what can I expect in terms of how misconfigured my templates are? Obviously, well, hopefully they're not vulnerable by design. So they shouldn't be, you know, there shouldn't be hundreds of misconfigurations identified, but sometimes there are. And this is, you know, why Bridgecrew exists. This is why Checkov exists. And one of the reasons, and actually one of the benefits of IAC that we haven't talked about yet, is that because it's in code, it's very shareable. And because it's shareable, this whole open source ecosystem has cropped up to support it. So being able to share little IAC snippets, whether it's a Helm chart or a Terraform module, is a super, super benefit of infrastructure as code. It gets you to hello world super quick. You can sort of rely on the hive mind to get services up and running super quick. And it also comes with drawbacks, just as libraries, packages, they can have vulnerabilities. Your IAC templates can as well. So, you know, Stack Overflow gets a bad rap for the copy paste culture, but when it comes to infrastructure as code, there's lots of other sources as well. Of course, GitHub, there's tons of IAC examples. And for a long time, it was sort of like the only place to find it. But now there are a couple of really cool resources. On the top here, we have the Terraform registry, which is tons of Terraform modules. Some are contributed by like cloud providers themselves, and some of them are contributed by anyone. We also have a newer resource, Artifact Hub, which is all for Kubernetes packages. So lots of Helm charts and great reusable elements that is all about making it easier and faster to spin up cloud resources with IAC. But our hypothesis at Bridgecrew is, you know, this is great, it's fantastic, and it's crucial to the economy of infrastructure and infrastructure as code. But these are not typically designed with security in mind. And we're seeing some changes recently, but over the past year, we've done a little bit of research to sort of put some data where our mouths were. And we analyzed two of these resources. So Artifact Hub for Helm charts and the Terraform registry for Terraform modules. And our hypothesis was more or less confirmed. We found that in both instances, about 50% of all templates and or Helm charts contain misconfigurations. And it's important to note that some of these findings are incredibly relevant and really highlight the need for DevSecOps. Some of these, you know, we tried to filter results that were not relevant, but it's important to remember that misconfigurations don't always represent business risk, but nonetheless, these findings highlight that, you know, misconfigurations at the infrastructure as code level are important to be aware of, and that it's on individual teams and on individual developers to understand and fix these configurations when they're integrating them into their code bases. So knowing that, knowing what misconfigurations are, why you should care about them, where they come from, this is some guidance as to where to embed security guardrails, security policies, security tooling into the DevOps workflow. So broadly speaking, when we talk about DevSecOps or shift left security, there's sort of two camps, two areas where we can address security misconfigurations and where we should embed security guardrails or policies. We have build time, which is infrastructure as code configuration, and then we have runtime, so running cloud resources and workflows. With infrastructure as code, we have some unique considerations. You know, I think with shift left, it's always like, oh, well, it's so easy. We should shift security as early as possible into code so that, you know, it's much easier to fix them down the road. But with infrastructure as code, there's some unique considerations. On the one hand, as you move towards runtime, you have much more information available. And we found that until you see an object that exists in your Google Cloud or AWS environment, you don't necessarily always have the information that you need to understand whether it's correctly configured or whether a misconfiguration actually represents risk. So it's important to understand that. And then on the other hand, as I sort of mentioned already, as you get closer to the code, the time, you know, from a developer's fingertips as you're writing a line of code, it becomes a lot less expensive and time consuming and risky to fix any misconfigurations that might crop up. So it's not super cut and dry, like you need to shift security left and that's the only way. Especially, you know, as IAC is a little bit newer and we don't expect a full 100% implementation and adoption, you should think about it in terms of doing both. So on the one hand, being able to get early, fast, inexpensive feedback, and then on the other, being able to address issues as they come up. We'll also talk a little bit about cloud drift. So, you know, when issues inevitably crop up, maybe there's an SRE emergency, somebody panics, or somebody forgets that somehow that infrastructure as code is being used to provision or manage some part of your infrastructure, and somebody logs into AWS and they change something. And so that resource is then drifted from its infrastructure as code ideal state. So it's really good to have the visibility into both of those as connected and or, you know, independent visibility into code configuration and runtime configuration. So when we talk about security in the whole DevOps lifecycle, where are we actually talking? What are the tools? What are the processes? So from runtime back to code, of course, the furthest left, except for maybe in your brain or in your planning meetings or your design architectures, the furthest left that we talk about is your IDE. So being able to add, and I'll show some examples in a bit, add really quick individual feedback is a great way to encourage individual developers to adopt cloud security and understand what misconfigurations they might be integrating into their code. And then as you move further right, you can do local pre-commit linters to run maybe like batch tests before integrating, and then, you know, getting checks on your pull requests, embedding, scanning into your CI/CD pipelines, and then finally in runtime. So There's a lot of considerations, though, to take into consideration here. For the purpose of this, I think what's sort of more dependent on your specific security maturity and stack is, what your build pipelines look like, what triggers a build. Do your current QA efforts run continuously on every new pull request, every commit? Is it every branch? Is it only some branches? Does that line up with what security and compliance need? Are developers testing their work locally before committing? How many CI/CD pipelines are even in use? Lots and lots of questions that you should take into consideration when moving sort of right. And we'll give a little bit of guidance at the end as to how to approach implementing this strategy. But the sort of first and easiest way sort of harkens back to what we were talking about with Chekhov and the GOAT projects, is to really get that fast pre-commit feedback. So if we're talking about like a crawl, walk, run approach to DevSecOps, this is the crawl. So being able to, this is a screenshot of VS Code. So being able to have here, there's a couple on the market, but here's the free and open source Chekhov plugin. So being able to have this like super, super fast, very low hanging fruit feedback. It's like the Grammarly or the spell check of infrastructure as code security scanning is super valuable. It's harder to enforce because it's on, up to individual developers, but it's a great way to get really inexpensive feedback. So you can see here, there's an AWS bucket, there's the red squiggly line underneath it, and Chekhov has identified a bunch of errors. So all of those errors there represent misconfigurations for this particular resource. And as an individual developer, you can click to learn more about why that is misconfigured, why it matters, why you should care. I personally think that that's a really, really important aspect of DevSecOps. It's not just the security tooling, it's also the security awareness and the continuous training that happens. So being able to learn right then and there, hey, this is unencrypted and it's bad and this is why, is really powerful, especially for sort of more novice developers. And with the Chekhov extension specifically, it comes with a little bit more actionable feedback. So you can actually fix the misconfiguration right then and there. Maybe it's changing a variable from true to false, false to true, or it's actually adding new lines of code. So really powerful. And then before maybe you're ready to integrate a bunch of code, but you want to do a full file or directory scan, Chekhov can be run in the command line and will just return a real straightforward list of issues that it's identified. So these are both really just basic examples of how to get this pre-commit or IDE feedback for individual developers at their workstations before code has been integrated. But what about once it has been integrated? And this is where it gets kind of interesting. It becomes much more collaborative. It's more about bridging the gap between security and engineering. And it's a little more delicate. So we're now picking up the pace. We're starting to walk. We're adding some automation. This is really sort of the meat of this conversation. So how do we embed it into your CI/CD pipeline? There's also lots of commercial tools out there, including Bridgecrew, that have native VCS or SEM integrations that you can get sort of checks on commits, on pull or merge requests, so that you're really surfacing that feedback where developers are spending their time. Majority of engineers do not want to leave GitHub or Bitbucket or GitLab. They want to comment, they want to edit, they want to, be spending their time there. All of the code reviews happen there. So they want to get feedback there. And if they can see that right in the pull request or in their CI/CD pipelines, that makes this the possibility of actually adopting DevSecOps that much more possible. So what would this kind of feedback look like in a CI system? Here's a screenshot from GitHub, or two from GitHub Actions, what your job looks like. Really, really simple job, running checkoff, just as we did locally, but in your pipeline. And then what that feedback looks like. So it'll trigger the GitHub, the Bridgecrew or checkoff action, and it'll show you what the result is exactly from your CI pipeline. And you can also even build a trend graph. There's lots and lots of powerful stuff within GitHub or your CI/CD provider. Most of these tools are either designed to be extensible and integrated into your pipeline, or they have native integration. So definitely important part, especially of infrastructure as code. When we think about Terraform too, if you can get the Terraform plan output, so it's a little bit more representative of what it'll look like in runtime, that's a really, really powerful step to enforce policies and get that feedback. And it's a sliding scale. You know, you don't need to, which we'll talk about sort of in the closing, you don't need to implement all of these guardrails and block every single failing check. Even enabling or embedding this kind of feedback as a non-blocking step is still really, really useful. Just be careful that you're not surfacing too much noise and annoying people right off the bat. But getting folks acclimated is a really great first step. So lastly, we'll talk about drift detection and continuous runtime monitoring. Now we're in runtime. You know, shift left security is all about not doing security monitoring in runtime, but it's still important. Drift detection and getting that continuous monitoring is super, super important. And, you know, it's a little bit more of an entrenched part of the industry. So a really sort of another low-hanging fruit thing that you and your team should be doing if you're not already. As far as there's lots of cloud providers, native tools, open source tools, commercial tools. Regardless, it's important to check them out. As far as cloud providers tools go, there's AWS config, which you can use to assess, audit, and evaluate configurations in your AWS environment. It gives you continuous monitoring and dependency awareness and histories of resources so that you have full visibility of all configuration. For GCP, Cloud Asset Inventory gives a whole inventory of services. You can search, you can monitor changes, analyze IAM policies. And then for Azure Security Center does some policy management. Pretty solid, continuous new resource discovery, and the ability to sort of benchmark against security best practices. There's a network graph, really powerful stuff, likely hiding in your cloud provider already. There's lots of open source tools too. Prowler, which is primarily for AWS security assessment. It has about 180 checks or policies that cover best practices and some compliance frameworks like GDPR, HIPAA, PCI. It also integrates with Security Hub so that you can get sort of a unified view of all policies, and you can also create your own. Cloud Custodian and SecurityMonkey are two other examples of open source tools that gives you monitoring of your runtime environment. At Bridgecrew, we leverage Prowler to get that runtime visibility. These are just a few. There's lots of other independent and corporate sponsored tools like Cloud Mapper, CloudSploit, Hackbot, a bunch of other ones. Also, when we're talking about runtime security, IAM policies are really important. So there's a bunch of IAM which stands for Identity and Access Management tools. Cloud Tracker, Bridgecrew has one called Air IAM, which is sort of transforms your runtime IAM policies into Terraform right-sized least privilege policies. So really, really important part of cloud security in runtime and build time. And just to call out Bridgecrew itself, great sort of resource for runtime visibility. But most importantly, drift detection. I think that this is a really, really interesting use case. We're actually going to be investing more in this area very shortly. And I think it really just gives a fantastic connection between your cloud environment and your code. It's good to have either or, ideally both, build time monitoring and runtime monitoring. But if you can actually link the two and understand if something in runtime does not match your ideal state in IAC configuration, that's really powerful. And that's, the lines become a bit blurry because, there's sort of two outcomes. You can either have a cloud drift that is temporary and is a misconfiguration or introduces risk, and you want to revert that as soon as possible. Or it was intentional, maybe lazy, or, for whatever reason it happened and you want to make that permanent. So then you can transform that runtime new configuration into IAC. So when the next time that resource gets provisioned, that is the new state. So really, really important functionality. And important to sort of think about as a sort of advanced feature of your DevSecOps strategy. So when we think about how to practically implement a DevSecOps, cloud DevSecOps strategy, these are some pretty broad guidelines. I would just start by saying, of course, there's no one-size-fits-all strategy. Every stack is different, every team is different, everyone's has a different process. So just make sure that you know first and foremost who all of your stakeholders are across domains, engineering, DevOps, security, compliance. Make sure everyone is has a seat at the table, everyone is on the same page. And start with experimentation. Before you start playing around with these tools that I've mentioned, you really don't know how relevant the feedback is going to be. So start playing around with it. Start showing different folks. Maybe you have a security champion and you ask them what they think of the feedback, whether it's too noisy or, they're just not ready for it. This is sort of like always going to be the first step. Do not move on until you have buy-in on the experimentation. Start small, start with, one team, one portion of their infrastructure, and test. Use open source tools, don't invest too much. I'll give a shout out to Bridgecrew. We have a trial. We have a free plan as well if you wanted to go more of the commercial route. Lots of these commercial tools have trials. So there's really, really a low barrier to entry here when it comes to getting security feedback. Then, start testing, continue testing, start looking at the feedback as, in a public forum, maybe expand where you're testing, who's involved. And then once everybody's sort of happy with the feedback, start to scale. And once you start scaling, you're going to have to fine tune your policies a bit. Some policies are going to be totally irrelevant or way too noisy. You might need to write new policies. You likely do. So you might add more policies. You might also find out that you don't need to scan on every branch, or not every team should be subjected to the same sort of guardrail. So this is where this scaling is, all of this is going to become really important while you scale. You might also start looking at different compliance benchmarks. If you hadn't already, you might look at compliance benchmarks to start in different parts of your stack. And then finally, you'll iterate and start really governing each team, ideally consistently. You should iterate, you should review results continuously. You should be looking at everything very, very consistently. And I think at this point, you should start thinking about bridging the gap between code and cloud. That might involve implementing a tagging strategy. We just recently released a new open source tool called Your, which is an auto tagger for IAC that gives you a unique trace ID so that you can better connect your code and cloud resources to give you a little bit more visibility and connection between the two domains. And I think that that's sort of like also going to be an enabler for drift detection. And really, this is the time where you sort of tighten the guardrails, tighten how you're enforcing things, what's blocking what, writing rules around, whether only high and critical severity misconfigurations block builds. This is where, this should be pretty set in stone. If you were sort of tweaking it during the testing phase, at that point, it should be pretty set in stone. Again, this is very much high-level guidance. There's no one-size-fits-all strategy. And what I would just encourage, if you're just getting started, what I would encourage you to do is to start with some training projects, start getting that pre-commit local IDE feedback, and go from there. Start getting other teammates, colleagues involved. If you're the security champion, find other fellow security champions. Read as much as you can about infrastructure as code security, some of the quirks that each framework has. Of course, Terraform and CloudFormation are very different, just as GCP and AWS are very different. So based on your unique stack and your unique team, learn as much as you can, start testing, scale it out, and then start really getting everyone on board to continue governing these policies. And with that, I thank you all for joining. Had a great time chatting with you all. If you have any questions, I will stick around. Thanks so much.